welcome to another lesson of Math Magic with Jen. We are doing more third grade, this time division. So if you haven't checked out my video on multiplication, go do that first. But otherwise, we're going to jump into division. And of course, we're looking at Common Core methods with tape diagrams and repeated subtraction. So usually when division is first introduced, it's the idea of fair share or equal share. It's not like one person's getting 9 and someone else is getting 3. Everybody needs to get the same amount, okay? So if we have 20 cookies that we're sharing with 4 friends, right, how many will each get? Okay. So you have a collection of a set of things that you're going to distribute equally among a certain number of groups. So here I call them M things and N groups, but yeah, I mean, the idea of 20 cookies to 4 friends. Will it work out exactly where we have nothing left over, or will there be a leftover? Okay, now of course, the fancy name for having something left over is called a remainder. So there are times when you will have problems with the remainder, okay? If it does work out exactly where there's nothing left over, that's when you're talking about having a multiplication fact that's been flipped, okay? So the idea of if we take 20 and we share it between 4 and we get the number 5, then that is the same, or it's a fact family with 4 times 5 is 20. Okay. Whereas if I have 20 and I divide it between 3 people, we are going to get a remainder. So when this comes here, this is saying that 3 times, there's nothing that when I multiply it by 3, there's no whole number that when I multiply it by 3, I get 20. Okay, so this is not going to happen. That's the difference between problems that have a remainder and those that don't. So if they don't, they're a flipped multiplication table fact. Okay, so how can we talk about this? Well, of course, we're going to do tape diagrams, because that is the language that third graders already know. So the difference here for me when I'm doing division is I am thinking of it as at least counting things out, okay? So when I say that, here I know you can just see that 18 divided by 3 is showing the number 6, but what I would probably have students do is have 18, and we're gonna fair share 18. So we're gonna count out 18. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And that's how we're getting this picture. Now, do I want students to get to the aha moment where they're like, oh, 3 times 6 is 18. So wouldn't it just be 6, 6, and 6? Yes, of course. But again, think about that introduction. We want them to have that aha moment, the whole class, every student. So it might take that idea of counting them out. It is a little tedious. You would definitely need to have some time allowed for this in your class. But if you have them working in groups, table partners, table groups, and then it might go a lot faster. But here we'd fair share 20 among 4. So again, we would count out 20. And so if we ended up counting out 20, so there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Now, the nice part about this method is that when you have something that does have a remainder, the students are going to see it, okay? So here they're saying that there's not a remainder, that each person, each group is getting 5. So here 20 divided by 4 equals 5. Okay, let's talk about a remainder. What's that going to look like? Okay, so here I've got 13 pieces of candy are to be shared between 5 friends. How many pieces of candy will each friend get? All right, so we're going to do our tape diagram. We've got 5. Okay, and I'm counting out 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we could have students start counting out 11, 12, 13, and they're going to have that moment where they go, oh, there's not enough. So are some friends going to get 3 and some are going to get 2? That's probably not very fair. We're not going to try and cut the candy into bits. So instead, what's happening is that we end up having 10 with 3 left over. Okay, so what's going on, sorry, I should write a total of 10, is that 13 divided by 5 is giving us the answer that each person is getting 2, but we're going to have a remainder of 3. So each person is getting 2 pieces of candy, and there's 3 left over who, I don't know who's getting that 3. Okay, so as you can see here, did this problem have a remainder? We could ask our students about that. Of course, they're going to say yes, we have some left over. And then, is there a way to know ahead of time? Now, that's basically trying to get them to think about, is there a multiplication fact? Like, think of their multiples of 5. 5 times 1, 5. 5 times 2, 10. 5 times 3 is 15. So was there a fact in this group which was 5 times the number's 13? Okay, so again, if they're very fluent on their multiplication facts, they're kind of going to know ahead of time if there's going to be a remainder or not. Okay, if you have students that are still struggling on those skills, that's okay. They're going to build it. Here again, I'd have them work with tape diagrams to show it. Okay, there is another method which is called repeated subtraction, just like we have repeated addition. This one's a little bit weirder, I think. I think it's a little bit easier to see it in your brain if you think about this idea of handing stuff out. Okay, so let me show you. So here it says 8 divided by 4 is asking how many times can you subtract exactly 4. Okay, now that may not seem obvious, but here's the idea. Remember our good old tape diagram? Of course you do. So if I'm going to have 8 things and I'm going to divide it by 4, the idea for repeated subtraction is we're saying, okay, I got to hand out 4. Okay, so if I have 8 and I just handed out 4, how many do I still have to hand out? 4. Okay, well, let's do it again. Let's hand out another 4. Okay, notice that each person in my tape diagram got 2, and notice that I subtracted 4 2 times. So what this subtraction is doing is it's saying, hey, I handed out one group of 4, right? Everybody got 1 each, which was a total of 4, and then I did it again. So for me, repeated subtraction kind of works best illustrating it with handing out a tape diagram, and then you could just practice it separately. So for this problem, again, if we're going to illustrate what's going on, we're saying we have 12 items. I'm dividing it by 4. So I'm going to hand out 4. So that's the first 4 that I handed out is right here. I'm going to count out another 4. And then I still have one more 4. So I subtracted 4 3 times to get a total of 3. Okay, I'm going to do one more up here on the screen. So if I had something like, how about 18, and we're going to divide it by 6. This actually might be the next one. It's pretty close. Okay, if I have 18 and I divide it by 6, what this is saying is that I'm going to hand out 6. I got 12 still left. I'm going to hand out 6 again. I have 6 left. I'm going to hand out 6 again. Okay, how many times did I subtract 6? 1, 2, 3. So because I subtracted 6 3 times, that is the same idea. All right, so let's go see my story problem that I quickly flipped and then came back. A baker made 19 cakes to be delivered to 3 restaurants. If the restaurants must each get the same number of cakes, then how many cakes will each restaurant get? Are there any leftover cakes? So if we're going to use repeated subtraction, here we go. I'm going to take 19, and what we're going to do is we're going to subtract 3. Actually, I'm going to write it over here. I want some more room. I have 16 left. Do it again. I have 13 left. Do it again. I have 10 left. Again. I have 7 left. Again. 4 left. 1 left. Okay, so what's happening here is that I subtracted 3. 1, 2, 3, 4, 5, 6. So because I subtracted 3 6 times, then what we're finding out is that 19 divided by 3 is 6. And we did have a leftover with a remainder of 1. Whew. Okay, can we use a tape diagram? Of course you can. What's going to happen with that tape diagram, and I'm just going to do it quickly, is that we'd have students remember this idea. Oh, it's 19 divided by 3, and I was doing 6 here. Better. 3 restaurants? Okay. See, even teachers sometimes make mistakes, and it's okay. All right, so of course, we'd have students count, and what they're going to end up with is that they're going to end up finding out that when they hand it out, they will hand out 6. They count it all out, and they'll have that 1 left over. 1 left over. All right, let's talk about some fun activities with division. These are some that I found from other people's creative minds because there are plenty of creative ideas out there that people are willing to share. I like this one here because if you like tactile objects, you could, and want to work on fine motor skills, still in 3rd grade, which is totally great, egg cartons. So what I would probably do is I would probably cut this in half so it looks more like a tape diagram, but long and skinny. That's just me. So 1 egg carton would make 2 tape diagrams. It looks here like they're doing jelly beans. I would not bring candy to a classroom. Instead, maybe you could just use the units cubes from the base 10 blocks. You could use pom-poms if you had some beads, whatever you want to do so they could count. But this would illustrate, right, the fair share that we've been doing. Another creative idea was somebody came up with a game board. So you could either create your own game board or you could reuse a game board that already exists. And here they have toy cars. And how they move is not by rolling dice, it's by picking a card and solving it. So here we've got 72 divided by 8. So whoever gets that card gets to move their space 9 places. 14 divided by 2, they get to move it 7 places. So again, it's that idea of practicing math facts and doing it in a fun way that's a little competitive. You could also, I mentioned in a previous video about like a PE activity, you could also do this. You could say, okay, whatever student's turn it is, you are going to move 72 divided by 8 steps, and then they're going to do it. So again, kind of like Mother May I or red light, green light, they're going to move however many steps of the division fact that they've got going. Okay. You could have kids lead it in small groups. I mean, you could see what you want to do. So that's our division. If you're thinking, Jen, you didn't cover long division, that's another video. So yes, there's a separate video for long division. It's a little bit more intensive, but for right now, that is our intro to how division works starting from 3rd grade basic concepts. Whew. Feel like I've done a lot. I hope you're having a great day. Good luck with the rest of your day. I hope learning goes great for you and your students. Have a wonderful one. Bye-bye.